Okay, now from a configuration point of view, we're going to see this is really straightforward. Okay, you turn the feature on or install the feature depending on which platform you're working with. Okay, on 5K, 6K, you just say feature FEX. On the 7K, you say install feature set FEX. Then you configure which links are connecting to the extenders. So we change the switch port mode FEX fabric. We give it a module number. We say FEX associate, then give it a number. And then the FEX is going to be discovered. Okay, if the version of code needs to change from the parent switch to the extender, it happens automatically. So when you do like an in-service software upgrade and you change from, let's say, 7.0 up to 7.2, once the code change is done on the parent switch, it downloads that to the extenders, and then one at a time the extenders will load the new code, reboot, go on to the next one, load the code, reboot, and so on and so forth. So the FEX and the parent switch are always running the same major version of code, and then if they have a different sub-release, the parent is automatically going to download it to the extender. There's a question, do I have the slides for this presentation? Yeah, let me add them in the file share. It's only this one plus one more afterwards. Most of this we're going to be looking at on the CLI. Okay, beyond this, the one other caveat that we need to look at is the server ports that are going from the extenders downstream. These run as spanning tree edge ports, and they run BPDU guard. Okay, what this means is that when you look at your physical wiring, you cannot use a fabric extender to connect to another downstream switch. Like if you were to plug a 3750 into the extender is going to disable the port because it's listening for the spanning tree information coming in. Okay, there are some workarounds for that, but in a good design, as best practices, you don't attach switches to extenders. You only attach your end hosts, like your servers or whatever the end, whatever the end stations are. Okay, there was a note here. The difference between the some of the generation of the FEXs is the native 40 gig uplinks versus the 4 by 10 gig uplinks exactly. So one of the things that we'll look at from a configuration point of view, and we're going to revisit this when we get to UCS, is the notice of pinning the traffic from the extender's southbound interface to the northbound uplink, and then how load balancing works a little bit different with the extenders and the I/O module of the UCS Blade Series chassis as compared to the regular switches. So when you look at a 40 gig Ethernet port versus 4 by 10 gig ports, it's more efficient to have a single 40 gig port as opposed to having 4 by 10. Even though as an aggregate bandwidth they're all equal, that it's both 40 gigs, it means that an individual flow cannot go above 10 gigs for the 4 by 10 channels, where theoretically it could go up to 40 gig if the server is, has the enough memory, CPU, etc., in order to actually support that. Okay, but it also means it limits as to what parent switches that you can talk to. If there's 40 gig uplinks on the FEX, then you need a 40 gig downlink from the parent switch in order to get to the extender. There's a question, does the VN tag impose a limitation for jumbo frames? No, it does not. Okay, so you can use 9216 and then still have room for the VN tag because it's a custom function of the ASIC. There's a question, can you attach a V-switch to the FEX? Yes, you can, because the virtual switch is not running spanning tree. Okay, if the virtual switch were to send a spanning tree frame, a BPDU, to the extender would then disable the port. But as long as you're not bridging between the interfaces of the V-switch, which normally you're not supposed to do, then it's not going to cause a problem. Because from the extender's point of view, it's just looking like an end host. Okay, so next let's talk about what we're going to be doing here in our particular topology. So if we take a look at the overall physical diagram, we're going to be working on rack 1 here. And we have two different extenders that are attached to a UCS C server. Okay, for each of the extenders, we have two links that are going to the parent switches. Okay, we have ports 21 and 22 on 5K1. We have ports 21 and 22 the other way. Okay, then we have 23 and 24. Okay, so first we're going to look at just using a single extender to talk down to the server. Then we'll combine two extenders together and look at running a virtual port channel down to the host. Then we'll look at the variations where We're doing a virtual port channel from the parent switch down to the FEX. And then finally, doing a virtual port channel from the parent switch to the FEX and from the FEX to the end host, which is going to be the enhanced VPC. So more so than the configuration, the big portion about this section is to understand from a physical design point of view what is or is not supported in order to do with the extenders. Okay, so the first thing we're going to do is let's get on to the GUI interface of the UCSC survey server.